Okay, we're back. In the last video, we said we wanted to take a look at the graph of y equals x cubed minus 19x minus 30. We agreed it would have this kind of end behavior. This could have conceivably 3 x-intercepts. Okay, it's not going to factor by any ordinary means. And again, the negative 30 as the y-intercept is a dead giveaway as to what my x-intercepts are going to be. So we're going to list all those possible factors of. So a is a factor of 30, which of course is 1 or 2 or 3, 5, 6. I guess we got 10, right? 15 and 30. So that's an extensive list, and all those could go positive or negative. Positive or negative. So this 1, 2, 3, 4, 5, 6, 7, 8, 16 possible factors. That's a lot to play with. So we're going to try to eliminate some. Again, we're in all likelihood not going to entertain these large factors. So just for making the number crunching a little easier. Okay. We also should probably see f of 1 would be 1 minus 19 minus 30. That's not going to go equal to 0. Negative 1 is not likely to end up equaling 0 either. You know, we'll probably go to something like 2. Okay, and so let's see what happens evaluating the function at 2. So evaluating the function at 2 yields 2 cubed, which is 8, minus 2 minus 2 times 19, which is 38, minus 30. Well, that's not getting me to 0, but I'm going to try the negative value. So I'm going to try f of negative 2, which will give me negative 8, okay, and then plus 38, and then minus 30. So good, I've got it. This will equal 0. So we have an x value equaling negative 2. That's an intercept of negative 2, which is to imply x plus 2 is a factor. Now, this time around, we're going to try the long division. Okay. Now, with the synthetic division. With the synthetic division, we're simply going to play with the coefficients. So we're going to list the coefficients here, which are 1 for the cubed expression. There is no x squared, so we have to account for that with the 0 as the coefficient. Okay, the x squared. We just got it's a space saver. You got to put it in there. You got negative 19, and then we have negative 30. Okay. Now, the synthetic division works in the following way. What we do is we take the intercept value. So the intercept value is the negative 2. We're going to slide that out here. Okay, we're going to kind of box this off here, as it were. Okay, we're going to bring down the first term. Okay, to the this is the 3 lines of computation. Bring down the third line, the first term, which is 1. 1 times negative 2 is negative 2. We add the column that gives us negative 2, right? Okay, negative 2, okay, times negative 2 is positive 4. Negative 19 and positive 4 is negative 15. Negative 15 times negative 2 is positive 30. When we add, we get a 0. We're in good shape. That's what we want. We want this last column to 0 out. If it doesn't, then we have to try another possible factor. So again, here's what the synthetic division goes for. Inside of the box, we have listed the coefficients of our x terms. And we have to account for the missing term x squared, which has a 0 coefficient. Okay? Outside goes the x-intercept value, which was, comes from the factor x plus 2, which is our factor, but our intercept is x equals negative 2, okay? So that goes out there. The first term comes down to the third line. Then you start the multiplication. 1 times the negative 2 goes in this position here. Add gives you negative 2. Negative 2 times negative 2 is 4. Add gives you negative 15. Negative 15 times negative 2 is 30. Add. That's great. So what we know now is that since this was x cubed expression and we divide it by a monomial, the resultant is an x squared. And here it is. These are the coefficients of the resultant division. So we've got x squared minus 2x minus 15 resulting from these items. And we had divided by the x plus 2. So this thing is essentially factored. We have a quadratic over here, which we're going to factor as what? X, so 5 and 3, I guess. X minus 5 and x plus 3, along with x plus 2. So that is our factored polynomial function, which will, of course, give us the intercepts that we need. We had an intercept on the y-axis at negative 30, so we can just kind of fake out where that's going to be. Let's get the kind of a rough graph of that going. Okay. And so we have the intercepts at negative 2, negative 3, so negative 2 and negative 3, and at positive 5 out here, and at negative 30 all the way down here. It's maybe a little off scale. We said initially what our shape was going to be up here, so we're going to thread the shape through those points, rising, going through the negative 3, going through the negative 2, coming down. Well, I'll rescale that, and then going back up, and then here it is. So we're going to kind of rescale that since I missed my negative 30. So that's the idea, though. Okay, so there you have it. There's another example on graphing the polynomial functions using this synthetic division, but using the same starting point as the other example by sampling the factors of this last term and plugging them in. Hopefully one of them will work for you. I mean, the ones I give you are designed to work, so just be patient with it, and start with the small factor values and keep at it, and you'll be fine. Okay, all right.